The asteroid belt is one of the most fascinating elements in our solar system. It's a vast region located between Mars and Jupiter and home to millions of space rocks, ranging from tiny pebbles to dwarf planets like Ceres, the largest object in the belt. Understanding the asteroid belt's origins, its makeup, the massive economic potential it holds, and ensuring the safety of our planet are all reasons for discovering more about this mysterious area of our solar system. The asteroid belt could unlock endless untapped resources that can play a key role in the future of space exploration. It could also be the source of an apocalyptic event here on Earth. The asteroid belt is a relic of our early solar system. 4.5 billion years ago, the solar system formed from a massive cloud of gas and dust. As planets began to form, some regions were disrupted by the gravitational influence of the massive gas planet in our solar system, Jupiter. Its immense gravity prevented the material between Mars and Jupiter from coalescing into a planet. Instead of forming into a single body, the leftover chunks of rock and other system debris remained where they were orbiting the Sun, giving rise to the millions of objects we now call the asteroid belt. Some of the material was ejected into the solar system or collided with other planets, but a significant portion remained. It created an area of space in our backyard filled with millions of asteroids, both big and small. Any one of them can contain a massive deposit of valuable minerals or be the one that threatens Earth in a future apocalyptic collision. It's both a blessing and a curse. The asteroid belt contains a wide variety of space objects, each with its own composition. Most asteroids can be categorized into three main types. Carbonaceous asteroids, or C-type, make up about 75% of the asteroid belt. They contain carbon-rich materials and are some of the darkest and most primitive bodies in the solar system. Scientists believe that C-type asteroids may hold clues to the conditions present in the early solar system, and even answers as to where we come from. Silicaceous asteroids, or S-type, are composed primarily of a combination of silicate rock and metals like iron and nickel. They account for about 17% of the asteroids in the belt and are brighter than C-types, reflecting more sunlight off of their partially metallic surface. They contain some, but limited economic potential. Metallic asteroids, or M-type, are rare and composed primarily of metals, particularly nickel and iron. They are highly reflective and contain valuable materials that could be crucial for future space exploration. The asteroid belt also contains Ceres, a dwarf planet that accounts for about 1/3 of the total mass of the asteroid belt. Measuring nearly 600 miles in diameter, Ceres is a fascinating object that appears to have water ice beneath its surface, which would be an invaluable resource to propel future missions into our solar system. While the asteroid belt may seem like a calm and orderly region of space filled with potentially valuable rocks, it contains thousands of objects that are considered massive when describing an asteroid. These asteroids, which scientists call near-Earth objects, or NEOs, are asteroids and comets that pass close to our planet's orbit and pose a real threat to our civilization. Collisions with asteroids here on Earth have happened many times in the past and have caused catastrophic damage. One of the most well-known impacts is the Chicxulub impact around 66 million years ago, which led to the mass extinction of the dinosaurs. Smaller impacts happen more frequently, like the 2013 Chelyabinsk meteor in Russia, which caused widespread damage and injuries. While large asteroid impacts are rare, it only takes one to dramatically change life on Earth as we know it, or to cause an extinction-level event that ends human civilization. The asteroid belt may seem far away, but in astronomical terms, it's in our backyard. It ranges from 110 to 205 million miles from Earth, depending on where Earth is in its yearly orbit. It could easily send objects hurling through space to the inner planets, as gravitational interactions with Jupiter can jar them loose, sending them on a collision course with us. It's crucial to study and monitor the asteroids that circle our Sun in the asteroid belt to understand all of the potential threats, both big and small. Even a small asteroid can have a devastating effect on our planet. But exploring the asteroid belt is not just about understanding potential threats. It's also about unlocking the massive potential and economic gain which would in turn fund scientific discovery. The asteroid belt contains asteroids that are rich in metals like iron, nickel, and cobalt. Others contain rare metals such as gold, platinum, and palladium, valuable for advanced technologies and renewable energy. Certain asteroids also hold carbon-rich compounds and water, both of which could be vital for future space exploration. Among the most lucrative asteroids are the M-type metal-rich asteroids, such as 16 Psyche, which is estimated to hold $10,000 quadrillion worth of metals. This astronomical figure exceeds the Earth's global economy many times over. Platinum is essential for a wide range of industries, including electronics and renewable energy. At $1,000 per ounce, its price demonstrates its value, and demand is only expected to increase. The wealth contained in platinum-rich asteroids could dwarf Earth's reserves and dramatically change our ability to explore the solar system. Asteroids like 241 Germania are believed to be rich with platinum, and if mined successfully, could supply more platinum than what currently exists on Earth. It could reshape how we explore the outer reaches of space and fuel the development of new technologies that rely on these scarce materials. But water may be the most valuable resource that seems abundant in the asteroid belt. Essential for life and space exploration, water can be split into hydrogen and oxygen, providing fuel for rockets and air for astronauts. The high cost of transporting water from Earth to space makes asteroid mining crucial for future space missions. C-type asteroids, which are rich in ice and organic compounds, could provide the resources needed for space-based refueling stations and long-term missions beyond Earth. Asteroid mining could even reduce the need for environmentally harmful mining practices here on Earth and pave the way for sustainable space exploration. The asteroid belt holds valuable information about the early solar system, as these ancient bodies have remained largely unchanged for billions of years. Studying their composition and structure may allow scientists to uncover clues about the formation of planets, the distribution of water, and the origins of life. The wealth of scientific and economic possibilities in the asteroid belt seems endless, but what may be a huge economic and scientific asset in space could also be the source of a major asteroid that collides with Earth. Only by exploring the asteroid belt can humanity gain a better understanding of all its possibilities and all of its dangers. Missions to the asteroid belt may be the key to unlocking the next great leap in our quest to explore and utilize the vastness of space. We thank you for watching and hope you enjoyed your time with us, and we will see you next time in a godless universe.